Alright, so this is my terrain generation project. I'll press play here. Ooh, camera was a little wonky at the start. So as you can see, I have this little camera controller. You can move left and right, up and down, and you can use the mouse to look around, which rotates the camera. You can scroll in and out, which changes the Z position. And if you press the space bar, it locks the camera and basically stops the input. And here it brings up this terrain modifier. I can adjust the height, adjust the water level. And these two here initially I had these renamed to something different because I thought it would be readable, but I've since changed them to what they are because I figure someone messes around with them enough, they'll kind of get the idea of what they're doing. But yeah, see, I got some pretty cool looking terrain. And you can do this little drone movement around and view the map. I'll jump into some of the code. So as you can see here, I have all these field variables up here that are just editable in the inspector. And down at the bottom, I have this onValidate function. And what this does is if the editor values change, then changes it dynamically. So basically check if the values are changed and generate the terrain if they did. And up here, I'm initializing the default height using an animation curve. I have different keyframes here. And here I have a generate terrain method. Kind of handles the entire generation cycle. Could probably be separated, but does have one functionality in a sense. So my generate mesh function creates a new mesh and applies a filter. Create shape generates the height map and creates the mesh data using the height map. And as you can see here, generate height map calls this calculate height and applies it to the height map. And if I go in here, well, this function here, I have a set number of octaves that you can modify in the inspector. And I'm generating some sample noise, which is scaled by the frequency. And then basically I stretch it to a -1 to 1 range to account for peaks and valleys, sorry. And then I apply that to a height curve. I have to normalize it first because it's gotta be between 0 and 1. And then I'm scaling the amplitude by the persistence and the frequency by the lacunarity, each octave. And here I'm just accounting for the fall off at the edges of the map. And that's also tunable in the inspector. And here I'm creating the mesh data, getting the vert height from the height map that I generated previously. Then I assign those to the vertices, and assign the UVs. Here I'm using a pseudo-random number generator to generate a bunch of offsets, which I then pass to a array of vector 2's. And here I'm creating triangles for the mesh based on the vertices. And here I'm generating the colors, normalizing the height between the minimum and maximum terrain height and then clamping it, and then I get the color based on height. Here I have a bunch of zones defined for different colors. I have snow, mountain, grass, sand, water, deep water. And here I have a blend factor using an inverse lerp. So I return the lerped color rather than just a color. So if it's between a mountain and snow region or between a water and sand region, then I get a nice blend effect. And otherwise, the base color would just be sand. Obviously, dependent on the water level. But yeah, I think this is pretty cool. And then update mesh is pretty straightforward. Just clears the old data and updates the mesh. And here in my camera controller is pretty simple. Just getting input vertically and horizontally and getting the mouse scroll wheel input. And then space to toggle the lock, which enables and disables the cursor and freezes the input. I'm also rotating the camera based on the mouse input. And my terrain modifier here, I have I'm using the old GUI simply because I like the look of it. It looks really clean. But I'm using a dirty flag. That way I don't have to update the GUI every frame. Sorry, update the mesh every frame, since every time a slider value changes, I'm regenerating the terrain to show the change, and it's very taxing to do that every frame. So if the values are dirty, then I apply the terrain modifications. Um, then I have two different windows, one for the terrain and one for the camera. Camera's active at all times, so player knows what they're doing. But yeah. Oh, what went right? Um, I was happy that generally all the project followed SRP, with some exceptions. I would say that the mesh generator in general could have been separated into more than one class, but when I started coding it, I focused on functionality and didn't get around to separating logic as much as I would have liked to. Honestly, I don't think it's too big of a deal because the class itself is not massive, and the methods generally follow SRP, so I figured it's all good. I was happy with the result and that I took an extra mile. It didn't turn out as fancy as I would have liked, but I'm glad I got something functional and it looks pretty cool. And additionally, giving people the opportunity to mess around with the terrain in play mode was a nice addition. I think without it, it still would have been cool, but um, people like to tinker around with things, so I'm glad I added it. And what went wrong? There's not a ton of things that went wrong, other than just, meeting deadlines and trying to keep up with everything while getting more and more tired. I will say that deciding what variables I wanted players to be able to tinker with and what to name them wasn't very intuitive. For example, initially I called lacunarity irregularity and persistence roughness for the GUI. That way, if someone was, my thought process was if someone was reading it and they're not familiar with making games or anything procedural, they'd probably be like, what the hell is lacunarity and persistence anyway? But in hindsight, if they mess around with those values, they're gonna know what they're doing. So um, anyway, I digress. Um, and what did I learn? I learned a ton of new concepts. Initially, I experimented with a gradient using a height curve to color the map, but it looked really clunky, for lack of a better word. So in the end, I used an inverse lerp to blend colors based on various heights, and then I transitioned them smoothly between different regions like mountain, water, and grass. Um, so that turned out really cool. And in a more general sense, I learned how to generate terrain through code, color different regions, and apply water with the blending technique to account for transitions. So lots of stuff. Um, it's a lot more math involved in procedural than I don't know why I thought there wasn't, but I don't know, this project felt like a lot of math, a lot of messing around with Desmos calculator and also like reading reading different stuff online, going through different articles and seeing how other people approach problems was really helpful for me. And what can others learn from me? I'd say that the biggest thing is Google. I'd say without naming names, I did help someone debug their terrain project and they asked me if I knew what an error means. So I suggested copy pasting the error to Google, which instantly popped up a discussion post on Unity forums and had the specific error. So I think that Google's a programmer's best friend, and oftentimes I know for myself, I think that I need to figure out everything myself, but if you have no idea what something's telling you or if it seems vague, then there's no starting point other than research, at least in my opinion. And a key takeaway, some aspects of the project I would watch tutorials on and try out some code here and there. I'm not really trying to reinvent the wheel here, but one thing I found valuable was, if you do take code from somewhere, be it online or a tutorial, try and break it. I found it's a really good way to understand what it's doing if you don't already. But overall, I think this project was a valuable learning experience, and I have a much better understanding of interpolation and procedural concepts in general, and it was pretty fun. Yeah, that's about it.